Hi, so again, disclaimer, never done this before, so hopefully it's not too bad. I'm also kind of sick right now, so there's that. The first thing that I'm going to talk about is the definition of the composite functions and how to recognize and think about them like conceptually. Then like the derivatives of them, which is what they're trying to teach you, and then I'll go over some of the flip math example problems. So composite functions usually take on the form f of g of x. I teach it as parent and child functions, and I'll get to why later. But in this case, f here is the parent function acting on g, which is the child function, which acts on x. And the way I'm going to teach this is we're going to go back to what functions represent and how treating functions as new inputs produces like a composite function. So, for example, if we have f of x is our input, right? And f of x is going to be our output. For example, if we have like a graph, we put in some input x, and then our y value is going to be f of x. So yeah, a tip I have is start associating functions with the words input, like input and output. A good like visual analogy that you could use is imagine we have like a red function of some sort, right? We take in an input x, we put it through the red function, and then we get like a red x. So this would be our f, and this is f of like our original x. And using this notion of putting inputs and getting outputs through a function, let's suppose we have like g of x, right? What does this mean? I have an x, and I put it through some function g, and then I get g of x. And what composite functions are trying to show you is that these outputs can be an input for yet another function, let's say f. So f of, well, our input was g of x, so f of g of x. And you can even go further with like h and so on. But this is how I learned it, and I think it's a really good conceptual like analogy. So if you've understood what it means to treat functions of x instead of just x as inputs for other functions, then it's time to start recognizing what f and g are in your composite functions. So here we want to find x, or what f of x is, and what g of x is. And I use the parent and child analogy. Again, I'll get to why later. But g here would be our child function. So if you recall here, we do g first. A good way to think about this is like usually children have the priority over adults in like, I don't know, emergency situations, or like who gets the meals first. So the child has priority. That's what we do first. That's the inner function. And then we do f, and then we get to the parents. So this would be like the parent function, and that's the outer one. Uh, the reason why I use this instead of inner and outer is because sometimes if you see this, some people see sine as kind of the outer function, when in reality this is just sine x squared. So here f of x equals x squared, g of x equals sine x, and remember plugging in g into f. So f of g of x, f of, well, what is g of x? It's just sine x, f of sine x. And then I plug in sine x for every x in f. Remember, that's like uh, this part of the analogy. This would be sine of x squared. And this was our like x for f. So here are the lectures from the flip math practice sheet so we can quickly go over like defining what f and g are and noticing them from the function. So let's say h of x equals f of g of x. And then let's do the first one. So h of x equals sine of x squared. So I like to think of it as when I actually go to evaluate something, for example, like what is h of 3? That's sine of 3 squared. The first thing I'm going to do is square the 3 and then to get 9. And then I take the sine of 9, which I don't know off the top of my head. But the point is, I do this one first. So here, at least in this one, it's pretty easy to see that this is going to be our child function, g, and this is our parent function, f. Because g is what you do first, and then f is what you do after you do g. Remembering like x to g of x to f of x. The second one was h of x equals the square root of ln x. Here I will use the outer and inner analogy because it's a bit easier to see here. But this is both the inner function and the child function, if you want to think about it that way. So g of x equals ln of x, and then square root of x is our outer function, or this is also equal to x with 1/2. So let's check this. F of g of x, right? F of, what is g of x? Natural log of x. F of the natural log of x. And what this means, if you remember in like unit 1, remember when we had like f of x plus h? This is our input. So whenever we see an x in f of x, we put in x plus h instead of x. So that becomes that. So ln of x is going to be our input for x in f. I know that sounds confusing, but we literally just put in ln x into root x. And that's how we know that that's correct. So this is the last one where I'm just going to skip through because we should be familiar by the rules by now. This one, the inner and outer should be more useful actually, so I'll use that. So this is the innermost function, 5x, and sine would be the next one, sine of x, and then the last one is cosine of x. If this is going to be equal to f of g of h of x, notice that h of x equals 5x. I'll write these down. Why not? G of x equals sine of x, and f of x equals cosine of x. Because we plug in this into this, and then this into this. And I'll leave this as an exercise for you if you want to prove to yourself that this is equal to, or that they're equal to each other. Alright, so that should be it for the definition of the derivatives. So why did I spend 10 minutes or around 8 minutes explaining the definition and recognizing f and g? Well, it's really important when actually doing the derivatives. So now we can go into the derivatives. So we define the derivative of a function f of g of x, or we can call this h of x even. So h prime of x is going to be f prime of g of x times g prime of x. And this is something you're going to have to memorize. So I'm not going to go over why this works because you're going to have to trust me, but it's a very long analysis approach, and that's not something anyone wants to do right now. So instead I'll give this memory trick, I guess. Whenever dealing with you have f of g of x, right? So I kind of think about it as we have to account for two rates of change, the rates of change of f and the rates of change of g. So I know there's going to be a f prime term and a g prime term. F prime of g of x, because we're accounting for the change in f. This part you're just going to have to memorize that it's not x, that it's g of x. And then we're also going to account for the g prime of x, the change in g. And this is the one that everyone forgets, so hopefully that helps you. now that we've defined the definition of the derivative of a composite function, I can go over some of the problems here, which I just pasted it, but here. So for the first one, we have f of x equals x squared minus 5 to the fourth. If f here, because we use f and g like in our definition as well, if this is confusing, you can use u and v. I'll still use f and g though. So f, sorry, and g. G would be our inner function, or the child function. So what do we do first? Well, it's the inner one, which is x squared minus 5. And then similarly, we have f is going to be equal to x to the fourth. You can check this by plugging in g into f. Well, x squared minus 5 to the fourth is exactly that. F prime is going to be equal to 4x cubed because of our power rule, which we've done in previous units. And then g prime is going to be 2x minus constant 0. So now we can actually plug in our f, g's, and derivatives into our formula. Recall that f g of x, the derivative of this prime, equals f prime of g of x times g prime of x. Yeah, it's a bit confusing with the capitals, but bear with me. So treating g, right, as our input for f prime of x, we put this into here because g is our input. And that's going to be equal to 4 times, and everywhere I see an x, I'm going to put in g, which is x squared minus 5. And then this tells me to cube it. And then multiply by, don't forget, the g prime of x, which is 2x. And then I'm just going to simplify this to be 8x times x squared minus 5 cubed. And that's your answer. By now you should have like the basics down, so I'm not going to go over all of these problems obviously because I don't want like an hour-long video. I'm going to go over I'll go over 3 and 6 because they seem to be a bit more complicated, and then I'll go over the other types of questions later on. So 3 is sine squared of 5x. H of x equals sine squared of 5x. So be careful here. This is where the parent and child analogy would be good. This isn't sine of 5x squared. This is sine of 5x, the entire thing squared. So just be careful of that notation. So if you can see it, that there's 3 functions here, 5x, sine, and x squared, then here's where I can use the f and g again. I'll use red. So our outer function is x squared, and our inner function is sine of 5x, f prime. And I'll show you how I tend to do these derivatives, and obviously I'm biased, but I think that's the easiest way for me. So derivative of x squared is 2x, and this, we're going to have to use chain rule again to find whatever this is. So I'll use blue. We have a new set of f and g. And if you're to do this on your own, don't confuse these f's and g's because they represent different things, remember. Because in this one, we're finding the derivative of sine of 5x to find g prime of x for this. So just be careful of that. So we have the outer function sine x and the inner function 5x, f prime, g prime, f prime of, or f prime is just cosine of x, and then this one is 5. Recalling the chain rule, we have f prime of g, which is cosine of 5x, times g prime, which I'll put in the front. So this is, so g prime equals 5 cosine 5x. Now we can find the derivative of the entire thing. So f prime of g, 2, and this is my input for x, so 2 sine of 5x times g prime of x, which we found earlier, so 5 cosine of 5x. And just gonna write it out. And okay, for number 6, I'm gonna again show the method of like solving for g prime, and you'll have multiple like f and g tables. That's what I call it, at least. The first thing I noticed, I'll use right here for the first one. F g. First thing I notice is my outer function or parent function is t cubed, and then the inner one is t squared plus 1 over 2t minus 5. And in order to solve for the derivative of the entire thing, we again need g, f prime, and g prime. So f prime is straightforward. We use the power rule, and we can use another f and g table to find g prime, except this time we're going to use the quotient rule. You don't have to memorize all that, it's just, we're literally just solving for g prime. So I'll use blue for that, just so we can differentiate our f's and g's. So this is quotient rule, chain rule, so I guess that's important to clarify. T squared plus 1 is our top function, our bottom one is 2t minus 5, and both of these are just standard power rule, so 2t and 2. F prime 2t times g, 2t minus 5, minus g prime 2, and then f, t squared plus 1, over g squared, 2t minus 5 squared. Expanding this out, we get 4t squared minus 10t minus 2t squared, and then don't forget to distribute this negative. And reset my pen. Don't forget to distribute the negative to the plus 1, so that becomes minus 2, all over 2t minus 5 squared. Be careful. So we didn't actually solve for the derivative of the entire thing, we solved for g prime. Recalling our chain rule formula, f prime of g of x times g prime of x. And in terms of simplifying, I'll show all my steps because I know people would probably want that. So f prime was 3t squared. I'll keep it like that. 3 times, and g is now my input for t, so I'm just going to put in g. 3t squared plus 1 over 2t minus 5 squared times our derivative g prime, and this can be simplified to 2t squared minus 10t minus 2 over 2t minus 5 squared. What I did was I combined the like terms of 4 and negative 2t squared. So 4 minus 2 is 2, times t squared is 2t squared, times this thing, 2t squared minus 10t minus 2 over 2t minus 5 squared. Yeah, so it's a bit messy. I'm not used to this drawing tablet, but in terms of simplifying, I'm going to distribute the power to the top and bottom. So I have t squared plus 1 squared over 2t minus 5 also squared, because remember, a over b squared equals a squared over b squared. And here I can pull out the 2. So dividing the entire top by 2, because I factored out a 2, I get this. And if you notice, if I multiply the 2 out here, it's going to be the same thing as our numerator here, and everything else stays the same. So what now? 2 times 3 is 6 times everything else. So that, I'm not going to expand that out. This is probably simple enough. T squared minus 5 minus 1. This is because multiplication is, again, commutative, so if you multiply a bunch of things together, it doesn't matter the order of which you do it, as long as it's equivalent. Oh, I forgot the t here, sorry. And then here, I notice that these are the same term, so a to the c times a to the b equals a to the c plus b. So 2t minus 5, 2 plus 2 is 4, so 4. And that's our answer. So here's an example of a problem where you don't actually know the function, you just know specific values that are given by a table. And we can still use the f and g tables, which is my preferred method of solving for f prime of 4 in this case. So I'll use capital F and G just to not get it confused with these ones. So we're calling chain rule f prime of g of x times g prime of x, and I'll keep that up here. So first one, f of x equals g of x squared. I notice that my outer function, the parent one, is x squared, and the inner one is clearly g of x. F prime and g prime, by power rule, this is 2x, and g prime is just g prime of x. If you're confused how I got from this side to this side, I just took the derivative of both sides of the equation. So df dx equals power rule, so f prime is just 2x, and this one simply just took the derivative of both sides. And now, since we've defined everything, we just need to find f prime of 4, right? So we're going to plug in 4 for x. F prime of g of 4 times g prime of 4. F prime of something, which we'll find now. So g of 4, if we go over to the table at 4, g of 4 is 3. So f prime of 3 times g prime of 4. So 4 is my input, g prime is given to be negative 2. F prime of 3, well, if f prime of x equals 2x, then f prime of 3, I'm going to plug in the 3, so I get 2 times 3, which is 6, times negative 2, and that just gives us negative 12. I'm going to go over 2 more chain rule, like actually finding the derivative problems, and then I'll do a tangent line problem, and then one of like the AP type questions at the end that everyone hates, just so this video isn't longer than it should be. But I am going through all of the steps, but I'm going to start to go at a faster pace because by now you should have a good understanding of the chain rule. So outer function is going to be 3 to the x. G is going to be root x. You can check this. If you plug in g for x, you get 3 to the root x, which is the original problem. And you can also think about this again as, well, I do root x first when I actually go to evaluate f of something, like, I don't know, f of 9. 3 to the root 9, I actually take the square root first, and then I do the exponent after, so that's why f and g are f and g. This is natural log of 3 times, 3 to the x. If you don't know how I got this, you have to go back and do your basic derivatives, and this is 1 over 2 square root of x. And this is power rule. Remember, x to the 1/2, 1/2 x to the negative 1/2. And then in a different color, I'll combine everything. So I put g into f prime, ln 3 times 3, there's an x there, so I'm going to put in a root x because that's my g. And then g prime is 1 over 2 square root of x, and that's our answer. This one, just by looking at it, looks like I'm going to have to do multiple chain rules, so no problem. F is e to the x, this is cosine of 7x cubed. F prime is going to be e to the x. G prime is going to be what we're going to make another table for. So The f and g table for this one using chain rule is outer function is cosine x, inner function is 7x cubed, f prime is negative sine of x, g prime is going to be, oh, I keep forgetting the equal sign, 21x squared. So using chain rule, f prime of g, oh wait, there's no, ignore that. Putting g into f, I get negative sine 7x cubed times 21x squared. So if we fill in our table, we get negative 21 sine of 7x cubed. I forgot the x squared. It's 2 in the morning right now. I'm sorry. Now, putting everything together, we put in g in for f prime, so e to the cosine 7x cubed times negative 21x squared sine of 7x cubed. And I'm just going to write this in a more compact way. And that's your answer. And that sort of makes sense, right? Because we are, right, e to the x prime equals e to the x. You know, this part stays the same, and then we just have the derivative of this part. E to the u prime, where u is a function of f, or sorry, x, u prime, e to the u, by chain rule. Okay, so for this one, I forgot to screenshot it. Whoa. Okay, whatever. So this one wants you to find the slope of the tangent line at some point. I'll call it x naught. Well, in this case, it's pi over 4, and this is our function. So this looks like another repeated chain rule, so I'm going to use multiple colors again. First, we need to find the derivative of this, obviously, to find m. Oh, actually, it's probably equation for a line at x1, y1 is this. Wow, that's not right. What we're finding is m, the slope, with the derivative. So outer function of this equals x squared. G is going to be sine of 3x. F prime, G prime, 2x. And most of you can probably do this one in your head, but I'll use another table just for good practice. F equals sine of x, G equals 3x, F prime equals cosine of x, G prime equals 3, so cosine of 3x times 3. What's that? So our entire derivative is going to be, put that into here, so 2 sine of 3x times our G prime, 3 cosine of 3x. Simplifying this, we get 6 times cosine 3x sine of 3x. And remember, this is f prime of x here. Or if this was f of x. So y prime. We want to find the slope at x naught, which is pi over 4. So we need to find f prime of pi over 4. And since we've already found this formula, that's really easy. So just 6 times cosine of 3 pi over 4 times sine of 3 pi over 4. And where is 3 pi over 4 on the circle? That's this angle. I'm not going to get into trigger view right now, but this is pi over 4, 45 degrees. So 45, 90, 135. The coordinates of this point is cosine comma sine, and the coordinates of this point is negative root 2 over 2 comma root 2 over 2. because it's root 2 over 2 to the left and root 2 over 2 high. So 6 times cosine of that, which is this, so negative root 2 over 2, times sine, which is the y value, so root 2 over 2. And if you've memorized your unit circle, then that could have been done in your head. So negative 6, I'll pull out the negative. Root 2 times root 2 is just 2. This is 4, equals negative 6 times 1/2 equals negative 3. So our m, or our slope at pi over 4 is negative 3. So going back to the tangent line equation, we just need to find y1 and x1. Well, x1 is easy enough because that's just pi over 4. That's the location of our point of tangency. And y1 is just f of x1. And f of x1 was what? Sine squared of 3x. Sine squared of 3x. If I want to find f of pi over 4, again, plug in pi over 4, so I get sine squared of 3 times pi over 4. Our y-coordinate, we already found sine of 3 pi fourths, so this is going to be pretty easy. Root 2 over 2 squared equals 2 over 4 equals 1/2. So y1 equals 1/2. I'll write this in red. So our equation for the tangent line, remember, y minus y1 equals m times x minus x1. Oh, and also if you ever forget this, just remember the slope formula. Y equals y minus y1, x minus x1. What we did was we just multiply everything by x minus x1 to get this on this side, and that's how we get this. So that's where that comes from. But that's if you forget it. It shouldn't be too hard to remember. So our y1 is 1/2, as we found earlier. Our slope was negative 3, so negative 3, x minus, and then our x1 was 5 over 4. And that's our answer. Here's just a visual thing, just so we know what we did. So we had like y equals sine squared of 3x. If you notice at this point, or I think around that point has the coordinates of pi over 4, comma 1/2. This is x1, comma y1. And this thing has a slope of negative 3, which you can sort of see here. So about over 1, 1, and about minus 3. So dy, or this is a good way to think about it. So this is our dy, and this is our dx, because this is just slope, essentially, equals negative 3 over 1 equals negative 3. So just so you're not blindly plugging in numbers, we found y1 by plugging in pi over 4 in y. X1 was already given, and we found negative 3 by plugging it into the derivative that we found. Last question for this video, because it's 3 a.m., I'm sick, and it's already like 35 minutes long, so I'm going to call it quits after this. We want to find h prime of negative 1. So the solution on FlipMath showed the equation for the entire tangent line. I'm just going to do the questions asking me and only find the slope of the tangent line. H prime of negative 1 would be the answer. So recalling chain rule for the last time, f prime of g of x times g prime of x. Now we just need to find our f's and g's and make a table. So my f here is going to be the outer function, or what you do last, I guess. So that's just f of x. And g is the inner function, the child function, so 2x squared minus 2, minus x. F prime, this is a line, so the derivative of a line is always going to be constant, because if you think about it like y equals mx plus b, which is a general equation for all lines. If you take the derivative, the power of this is 1, so m times 1 times x to the 0 plus 0. This is also 1, so it's just m. And in this case, the slope is going to be rise over run, so it rises -1, or drops 1, I guess, and it's over 2. So the slope is -1/2, and that makes sense. So f prime is going to be always -1/2, and g prime is going to be the derivative of g, so just 4x minus 1. So f prime of g, notice how you can't really put g into f here because it's always constant. If you don't understand what I mean, if you have a line, it doesn't matter what your x is, your y is always going to be this constant. So for all x, f prime will be -1/2. I'll write this in a different color. So f prime of g of x is going to be -1/2, which means the first part is just -1/2. Don't forget the g prime. 4x minus 1 equals -2x plus 1/2. And then remember, we wanted to find the slope at -1. So this is h of x. H prime of -1, we just put in x equals -1. So 2, -1 plus 1/2. This is 2 plus 1/2 equals 5 halves.